Hi folks, welcome back to Math with Captain Rod. The purpose of this video is to demonstrate how to use properties of logarithms to shorten up some differentiation processes where appropriate. So what we're going to try to do here is we're going to try to calculate the derivative of this function, square root of x squared plus 1 times x minus 1, the quantity squared. And we could differentiate that thing as it sits, no problem at all. The outer function is a square root or a 1/2 function, and then we have to apply the product rule on the inside. It'd be a little bit of a long drawn out process, but one of the little tricks here in math that we can do is we can shorten up these derivatives by using logarithmic properties. So what I'm going to do is I'm going to take the natural log of both sides of this thing first. So this is going to read natural log of y equals 1/2 times the natural log of x squared plus 1 times x minus 1 squared. Now, here's where the 1/2 came from. Think of it as this to the power of 1/2. So when you take the logarithm, one of the properties of logarithms is when you take the log of something to a power, I'll just put like x to the p here, the power can come out in front. So that's the property that I use to bring this 1/2 out in front. Now, also, this can be expanded out. So I'm going to write this natural log y equals 1/2 times. Now, the log of a product can be written as the sum of the logs. So this can be written natural log of x squared plus 1 plus natural log of x minus 1 squared. And one more thing I'll do, again applying this log of something to a power, the power can come out in front. This too we can put here. So I'm going to go ahead and just do that and erase it. All right. Now at this point, this is a pretty good place to differentiate this function because we've got it all down to nice, fairly simple terms. So if we differentiate this function as it sits, so again, what I'm going to do now is I'm going to apply the derivative as an operator here. We're going to differentiate this entire thing. Left-hand side, the derivative of natural log of y is 1 over y prime, or 1 over y dy dx. This is because the derivative of the natural log of anything is 1 over the anything. So if this were an ln x, this would be 1 over x. It isn't ln x though, it's ln y, and y is a function of x, so this has to be chain ruled. So the derivative of this term is going to be 1 over y dy dx equals, now I'm going to take this kind of term by term here. I'm just going to leave this 1/2 sitting here and go inside these parentheses and differentiate. So here we have ln of x squared plus 1. If we differentiate this animal, we get 1 over x squared plus 1 times 2x. That's coming from the derivative of the natural log function is 1 over, like the derivative of ln u is 1 over u, but then you have to chain rule it times du. Moving over to the next term, 2 times, right here we have an ln of x minus 1. When we differentiate that function, we're going to get 1 over x minus 1. Again, to chain rule times the derivative of the inside function, but that's 1. And that thing is done and now differentiated. Now, what we're looking for, remember, is dy dx. So what we can do now, if I want to solve this for dy dx, I have to multiply by y. And y is sitting right here. Here's an expression for y. So y prime is going to equal, and again, what I'm going to do now is multiply by y, and y is equal to the square root of x squared plus 1 times x minus 1 squared. So there's y, times this mess. I'm going to go ahead and move this 1/2 here. Take note that these are going to cancel. So the 2's are going to go away and leave me with x over x squared plus 1 for this product. And then when we look at this product, these 2's are going to cancel and just leave me with 1 over x minus 1. And there's our expression for y prime. So logarithmic differentiation is just a way to sometimes get around a little bit of work. It works very, very well when you have a lot of terms over here to the right. And the idea is you take the natural log of both sides first, apply properties of logarithms to separate off the terms into individual pieces, then differentiate, like we did from here to here, and then you typically solve for y prime. So, again, the purpose of this video is just to demonstrate how to use properties of logarithms to differentiate in a slightly different way called logarithmic differentiation. I hope that this helps demonstrate those properties. Have a great day.